Hey guys, welcome back to another video. In this video, we'll be talking about the unit circle. Alright, so let's get right into it. Okay, so to begin with, let's just start with the triangle definitions of trig functions. So what do I mean by that? So suppose we have some right triangle as such, and we have the angle theta right here. And so then the longest side of a right triangle, as you might already know, is called the hypotenuse. So I'll just abbreviate that as HYP. So that's the hypotenuse. Okay, and then the side opposite the angle, which is this side right here, that's the opposite side, right? So it's all relative to the angle theta. So this side right here is the opposite side, which I'll abbreviate as OPP. And then the last side, which is the side adjacent, because angle theta has two sides adjacent to it, right? The hypotenuse and this side. And so the side that's not the hypotenuse is called the adjacent side. So this is the adjacent side, which I'll abbreviate as ADJ. Okay? And so then we have three main trig functions that we can derive from this, namely sine of theta, cosine of theta, and tangent of theta. Okay, so the way that they're defined is that sine of theta is defined as the opposite side over the hypotenuse. So it's defined as opposite over hypotenuse. Okay, cosine of theta is defined as the adjacent side over the hypotenuse. So adjacent over hypotenuse. And then tangent of theta is defined as the opposite side over the adjacent side. So opposite over adjacent, right? So these are the definitions of the three main trig functions. And the mnemonic that is used to memorize this or to help us remember is known as SOHCAHTOA. So what it's saying is that sine is opposite over hypotenuse. So S stands for sine. So it's like sine is opposite over hypotenuse. And then C is cosine is equal to adjacent over hypotenuse. And then tangent is opposite over adjacent. Right? So this mnemonic can help us remember the three definitions, the three trig functions. Alright, cool. So as an example, let's just say we have like some right triangle like this, and this is the angle theta, and let's say it's like, right, those are the side legs, let's just say. And so we want to find sine of theta, cosine of theta, and tangent of theta. Right? So how would you do this? So remember, sine is opposite side over the hypotenuse. So the opposite side of angle theta is this side, which is 4, and the hypotenuse is 5. So sine of theta is 4/5, 4 over 5. Okay. Cosine of theta is the adjacent side over the hypotenuse, so 3 over 5. And then tangent of theta is the opposite side over the adjacent side, so 4 over 3. Alright. So yeah, that's basically SOHCAHTOA. Alright, so now we can actually move on to the unit circle. Alright, so suppose we have a unit circle in the coordinate plane as such. And unit circle basically just means that the radius is 1, right? So let me write that down. So unit circle, all this means is that the radius is equal to 1, right? That's what a unit circle is. So then now we can draw a triangle inside of this where the radius of the circle is going to be the hypotenuse of a right triangle. So that is one radius of the circle, right? And we can drop the altitude right here, and then you have this side as well. So this is the right angle, and conventionally we use this as the angle theta. Okay, so now what we have just created, this triangle is known as the reference triangle. So this is known as a reference triangle. Alright, and this angle theta is the reference angle. And the reference angle is always drawn from the terminal side, which is the in this case the radius of the circle, so like the hypotenuse, to the x-axis. So for example, if I had like another thing like this, right, you would always draw the angle right here, right? It wouldn't be that, like, this is not the reference angle. It's always from here to the x-axis. Okay, so that's just something to keep in mind. But anyway, so then we have a right triangle, and so then we can apply SOHCAHTOA to this right triangle. Okay, so first let's label this point, right? So this is a point with some coordinate xy, right? So what does that mean? So if this point is xy, then that means that this length right here must be x. So this length right here is x, okay? And this length right here, this height, is y, right? That's the definition of this point being xy. It means that the horizontal distance is x and the vertical distance is y, okay? And so then we'll just call this r, and we know that since it's a unit circle, r is equal to 1. So this length right here is just 1. All right, good. So now we can use SOHCAHTOA for theta. So sine theta, cosine theta, tangent theta. So remember, sine theta, so if you have SOHCAHTOA, right, sine is opposite over hypotenuse. So the opposite side is y over the hypotenuse, which is 1. So sine of theta is y over 1, but that's just y. Okay. And then cosine theta is adjacent over hypotenuse, so that's x over 1. So x over 1, but then that just is x. And then tangent of theta is opposite over adjacent, so the opposite side over the adjacent side, so that's y over x. Okay? But now this is really cool, because we just showed that sine of theta is equal to y and cosine theta is equal to x. Okay? So that means that we can rewrite this coordinate point xy. This is just equal to cosine theta, sine theta, right? Since x is equal to cosine theta and y is equal to sine theta. And so now we've derived a new way to express coordinates in the coordinate plane. And then tangent theta is y over x. So if you think about the slope of this line, the slope of this line is y over x, and y over x is equal to tangent theta. So that's why the slope, which we usually denote as m, the slope is equal to tangent theta now, right? So that's pretty cool. All right. So, yeah. So that's basically the way that we construct the unit circle. So now we have discussed the unit circle, let's discuss the signs of the trig functions. So whether they're positive or negative and which quadrants. So again, let's draw the coordinate axes. X, Y, right? Okay, so recall that sine theta equals y and cosine theta is equal to x and tangent theta is equal to y over x, right? So basically, in the first quadrant, so this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay? So in the quadrant 1, x is positive and y is positive, right? So if x is positive, that means that cosine theta is positive. If y is positive, that means sine theta is positive. And then tangent theta is y over x, so that's also positive. So that's why in the quadrant 1, right, everything is positive. So I'll say all is positive. Okay. Quadrant 2. In quadrant 2, x is negative, but y is still positive. So x being negative, that means that cosine theta is negative. Y is positive still though, so sine theta is still positive. But then tangent theta, you have a positive over a negative, so that's negative. So tangent theta is also negative. So in quadrant 2, we can see that only sine theta is positive. So sine theta is positive only. And then everything else is negative. And then quadrant 3, we see that both x and y are negative, right? And so that means that cosine theta is negative, sine theta is negative, but tangent theta, negative over negative, is actually positive. So in quadrant 3, tangent of theta is positive only. And then everything else is negative. And then finally, quadrant 4, I'll just write it over here. We can see that x is positive and y is negative. So cosine theta, x is positive, sine theta is negative, right? So positive, negative, and then tangent of theta is negative over positive, which is negative. So in quadrant 4, only cosine theta is positive. Okay, and then everything else is negative. And so then this helps us derive another mnemonic for the signs of the trig functions in the 4 different quadrants, and namely it's ASTC. Okay, so what does this mean? So each of these boxes, they represent one quadrant, right? So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, and so then A stands for all. So in quadrant 1, all is positive, right? In quadrant 2, S is sine. So in quadrant 2, sine is positive. Quadrant 3, tangent, T, is positive. And then in quadrant 4, cosine is positive. And so this basically tells us where each of the trig functions are positive. And for example, in like quadrant 2, we know that sine is positive. So that means that all the other trig functions in quadrant 2 that aren't sine are negative. So that's how we can use this. So if you want to think about it, you can think about this like coordinate axes as a plus sign as well, because these things tell you where the trig functions are positive. Okay, so yeah, you can just use this to help you remember the signs of the trig functions. So if you want to like try an example with this real quickly, we can. So suppose we have like let's say like cosine of pi over 3, right? So first you have to see where is pi over 3, right? Is pi over 3 in the first, second, third, or fourth quadrant? So if you can just draw this out real quick. And pi over 3 looks something like that. So it's in quadrant 1, right? And so then from ASTC, we know that in the first quadrant, all the trig functions are positive. So cosine of pi over 3 is going to be positive. All right, so I want to do like another one. Let's say like sine of 5 pi over 4. Okay, so we know that over here, this is pi, right? Because this is 180 degrees. So this is pi. And so then 5 pi over 4 is a little bit more than that. So 5 pi over 4 is like somewhere right here. So this angle right here is 5 pi over 4. But it's in the third quadrant. So then from ASTC, we know that in the third quadrant, only tangent is positive. And so that means that sine in the third quadrant is negative. So sine of 5 pi over 4 is negative. So that's just kind of how you can use ASTC to like determine the signs of the trig functions. All right. So yeah, that's pretty much it for this video, the unit circle. If you enjoyed this video, make sure to leave a like and don't forget to subscribe. I'll see you guys in the next video.